All right, we're going to check out these lessons here today for Tuesday, September the 8th. A lot to get through. A lot of it I think you can do on your own, so I might not actually get to every assignment, but we'll see how it goes. All right, first one is creating frequency tables. Frequency tables are real simple. They count how many times a certain instance happens in a set of data. All right, so on the top here is number of push-ups. There are 23 push-ups, right? How many times did 23 happen? That only happened once. 24 only happened twice. Or once, sorry, one time. 25 happened 5 times. And that's our frequency table. Easy enough, right? Okay, how many times was there one child? 1. We're just counting the number of instances in which a certain thing happens. All right, so that's frequency tables, easy enough. Next one is creating dot plots. So next is dot plots. All of these have to do with real simple data stuff, all right? So using this data, create a dot plot where each dot represents a concert. First, we're not sure what to do, but if you click down here, you notice you can drag and move however many dots there are. Pretty neat, right? So using this data, create a dot plot where each dot represents a concert. So let's do 0. There are 2 zeros in the data set. 1, 2, right there. There are 2 1s. 1, 2. So I'm going to go to 1. Right. How many times were there 2? Just 1. And 3 occurred in the data set just 1 time. Right? Our number of dots should match up to the number of items in the list. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. All right, that's a dot plot. All right, well, we're going to move on from there. Next on our list is reading dot plots and frequency tables. It's the same idea, but we're just going to translate the information from an existing dot plot or frequency table. First question, what is the most frequent height of a toddler? So the most frequent one, the most often occurring one, is the highest dot plot, right? So it should be 84. Let's try a different one. How many employees work at Tia's toy store? How many employees, right? Has nothing to do with the number of hours of sleep. Nothing to do with that. What we're going to look at is the total number of employees. So we're going to have to actually add up these number of employees, right? If we add up all those, we get 5, 6, 7, 8, 9. Again, pretty simple, straightforward assignment. All right, next one is creating histograms. Histograms, a lot of people think of as bar charts, so they're really not too far off. So a histogram is a lot like a bar chart, except for we're going to focus on a space, not just one number. All right, so in between 0 and 10, how many occurrences in our data were in between 0 and 10? Right? How many times was 0 and 10 a house visit? Right, so I just see one number. That's 9. So I'm just going to go up to 1. There was 1 occurrence in the data between 0 and 10. Between 10 and 20, 1, 2. Between 20 and 30, 1, 2. Between 30 and 40, there were 2. All right, again, our total number of days here, our total number of items in the histogram should match up to how many items are in the data. So 1, 2, 3, 4, 5, 6, 7. If we count up here, we should have 7 numbers. 1, 2, 3, 4, 5, 6, 7. There we go. All right, so that's creating a histogram. Almost done. Reading histograms. We read a histogram. How many cherry pies have 90 or more cherries? So the key question, or the key point in this, is it says 90 or more. So that could mean anything past 90. So that means we need to look at two different bars here. We need to look at that whole space. We need to add up the accumulation of each of those bars. So, for example, this one is 4. This one is halfway between 2 and 4. It must be 3. So how many cherry pies have 90 or more cherries? The answer would be 7. Be careful about the way it's worded in your question. Right? A lot of people just would have said the answer is 4 because they see the 90 right there. Make sure you read carefully. All right, almost done. Last one, reading stem and leaf plots. This gets to be probably the trickiest one because it's not something you see a lot. A stem and leaf plot, the name of it, stem and leaf, comes from the fact that this is like a stem or the trunk of a tree, so the stem of a stick, and these are different leaves that come off of it. The way to read this is to say this represents just the number 7 because the number in front of it is 0. This number represents 11. This number represents 14. This number represents 18 because they're in the row here on the stem and leaf plot that starts with a 1. They all start with a 1. This number here, for example, doesn't mean 17, it means 27. 27 occurs twice in here. All right, as you can see, there are no items in here that are in the 30s or 40s. And that's what the key down here is trying to tell you. Everything like that. All right, so here we go. What was the smallest number of tigers at any one zoo? So at one zoo, what was the smallest amount of tigers? And that was right here. And we would say 7. Let's do another one of these. How many department stores have exactly 37 pairs of sunglasses or of glasses? 37. So let's look on stem and leaf. We got to look for 30. Okay, so let's look here. Do we see a 37 anywhere? No. So that means no department stores had 37 pairs of glasses. There wasn't a 37. Okay. What if instead of 37, what if it had said, how many had exactly 43? What if there's a 43 there? Well, I look for 40. Then I look over here. How many times did I see 43? 1, 2. That answer would be 2 stores. Exactly 2 stores have exactly 43 pairs of glasses. All right, let's do one more. How many zoos have fewer than 18 slots? Again, watch how it's written to you. Fewer than 18. So fewer than 18 would mean anything below 18, not including 18. So I see this number, and that one. How many zoos had fewer than 18? Well, we have 1, 2, 3, 4. All of those are fewer than 18. All right, and that's all for today, all of those assignments.